Yeah, hello guys. I guess we are live now. Uh, if anyone can let me know in the chat if you're able to hear me and my screen is visible. Anybody, you guys can let me know if the screen is visible and I'm audible. Yeah. Am I visible, Satyam? Okay. Yeah. Okay. Yeah. Thanks. Yeah. Okay. So we'll do a recap of what we had done yesterday for the forensics class. Okay. Until then, we'll be waiting for the guys to come in. Okay, so we started with a file system and what the Indianness of a file is, uh, the two representations of the Indianness. Then we went to see what file number and magic number has, how they are associated with each other. Then we looked at the EXIF data of image files. Okay, and we did a few hands-on for file formats, magic numbers, and EXIF data yesterday. Then we talked about steganography, and in steganography, we did a little bit of encoding and decoding. I didn't talk much about keyed steganography because I thought that would be much out of the scope. Moving on, we did hands-on on steganography. We did see ADS, but I guess the way I showed it to you guys was not too visible for you to guys to comprehend it. Then we went to email forensics and how to get to know the email headers and determine if a mail is legit or not. Okay. So we did a basic theory on it and then not exactly a hands-on. So I guess on the last day, instead of streaming on YouTube, what we can do is we can have a final WebEx call where we can actually discuss your questions. Okay. Then we looked into so we didn't cover malware forensics yesterday because it was just a theoretical slide. So I didn't find a malware to show you a live demo, as in how to do the forensics for malware. So we just stopped right there, and then the rest is just critical. Okay. So if you guys did have some doubts for the yesterday's class, you can just ask me now since there are people yet to come. You guys can ask me doubts if you have. If you have any doubts, then two. Okay. So can you explain a bit more about ADS? Okay. So what I'll do is I'll do a screen recording of my laptop and share it on Slack. Okay. You'll be able to easily understand it. But do remind me to do so in the Slack. Uh, ADS is something that enables you to attach one file. See, NTFS is a file system which provides you with the features of streams. Okay, so given one file, you can have multiple streams in it. Okay, so every stream can be a huge image, video, text, anything. Okay, so the given file, when provided with a feature of having streams, it can contain any number of additional hidden files. Okay, that basically is ADS. So don't get too complicated with ADS because it is not much used, but it is a cool thing to know about. Any more doubts? Okay. And yesterday I did post a question to break RSA on Slack. So if you guys have any questions regarding it, you can ask me here. Yeah, can you do steganography once more? Uh, okay. So remind me at the end of today's class, because I hope today's class is a little short, so that either we can do it in the end of today's class, or I'll try my best to upload a video on Slack. Okay. Okay. Did anyone try to break RSA, the question that I posted yesterday on Slack? Comments, guys. Oh, you were able to crack it? What were the two prime numbers that you got, Dushyant? Oh, don't tell me here. You will spoil it for others. Yeah, don't provide it on the comment section. Yeah, message me on the Slack. Okay, oh, good. Can we do that question? P and Q are known. Oh, Shubham, I didn't get your question. Could you repeat that or rephrase it? Oh, you already posted the numbers on Slack. Let me just check that. So, if possible, can you delete the message, Dushyant? Because let people try to find a site that can actually factor this big number. Okay, so we'll wait for 3 more minutes and then we can get started. Okay. How to decipher now when P and Q are known? Okay, so we'll discuss the step 2 and 3 on the Slack. Once I finish today's class, I'll give you with step 2 and step 3 on how to proceed to crack RSA. And although I think that one requires public key of receiver to decipher it. No, you already know the public key of the receiver, Dushyant, because you know E and you know N. Okay. So you will need to know the D. So to calculate D, you should know P and Q. Yeah, good that you deleted the message. Thanks. Okay. Can you have the revision of yesterday's lecture? Sanjana, I just did that a while back, but it was not too much of a revision. So I guess yesterday I didn't do much, but what I covered was we covered file system, where we discussed about magic numbers, endianness, the file extensions, and the exif data. Then we did a little bit about steganography. We moved from steganography to ADS, and I'm trying to provide you guys a video of me doing ADS and steganography on the Slack. Okay? I'll try my best to upload a video there. Okay, so yesterday I didn't go through the slides totally because the last slides of forensics had theoretical knowledge for malwares. So I didn't actually go there because I was trying to find a way to get hold of a malware where we can really examine it. So if possible, I'll try to find that malware and we can do it after this batch ends. Is it possible to share your entire screen? Yeah, I guess. So guys, 1 second. Yeah, we'll start within a minute or so. One second, guys. Okay, so let's get started. So today we'll start off with web security. So I've segregated web security into two parts, today and tomorrow. Tomorrow will be handling. Before that, let's go on what we'll be handling tonight. So tonight we'll be going through the basics of web security, mainly the HTTP request response. Then we'll be doing a hands-on on Wireshark. Okay, and I guess there are much more. Okay, so we'll proceed. Okay, so to proceed with web security, we actually need to know what HTTP is. Okay. So HTTP is a hypertext transfer protocol, a protocol which uses or lets the server and client communicate with each other. So this was how it was introduced when they invented it. So to understand HTTP, you should understand three main aspects of it: the web request, the web response, and something called as MIME. But before trying to understand web request and response, you should know the three main central technologies of, yeah, I mean, web development as such, or web terminologies. So what a web does is it enables you to access something that is not currently on your computer. It can be anything. So it is generally considered a resource. So until and unless you know the name of the resource, you'll not be able to access it, right? So how to name a resource? That is done by uniform resource identifier or locator. Okay? That is where URI and URL comes into place. The next is how to request and serve a resource. So how to request is for the client, and how to serve a resource is for the server. That is based on this protocol called HTTP. Now, HTTP is a protocol which uses hypertext. In order to use hypertext, we need to know how to create a hypertext markup language. So these are the three basic things you should know before you proceed with web security. Okay. So just me summarize this slide in one sentence. You use HTML, the hypertext markup language, to create hypertext, which enables the HTTP protocol to serve and request a resource. and the resource is named using the URL or URI. So now let's see how a URI syntax is made. So this is a general method of how a syntax is made. It consists, the first thing it consists is scheme. The next thing is authority path. As you can see, the query and fragment are followed by the path. Now what is scheme? So the protocol that you use to request the source is the scheme. The authority which controls how to act, you know, how to understand or how to serve you the resource is usually the authority. So the authority is usually a server name. A server name consists of username, host, and port. Sometimes it is a domain name. Okay? So that is basically the same thing because the port is generally 80 because it's a web port, right? Web service. The next is the path. So from this authority, what is the path you're trying, as in what is the resource that you're trying to access or request is provided by the path. Next is the query. Now the query is what are you trying to, so for a given resource, what is the query that you're trying to do on that given resource is done by the query. And what part of that query is provided by the uh, fragment. Okay. So I guess you guys understand these basic concepts of URI syntax. Let's see some examples. So in these four examples, foo here represents a scheme, and this is the colon that is succeeding the scheme. This comes as the authority. Okay. So this is the port because since it is not 80 port or 80, so it is not an 80 port, as in it is not 80, it is 80 by default. But since they have changed their settings to 8042, they had to explicitly mention it. Until here, it is authority. The first slash, until there, it is authority. Then you have the path till here, followed by the query and the fragment to it wants to reach. So this is a typical example of a URI syntax. So in general, it is FTP, which is the protocol. FTP IETF.org is the authority. RFC slash RFC1808.txt is the path. So this doesn't actually have the query and fragment. So these are the examples that we can see. Okay. When you try to email someone, the actual thing that acts as a hyperlink is this. The protocol is mailed to followed by the colon, and this is the authority. Okay. That is the reason whenever you click on an email link which you find on the website, it generally opens you a new tab which consists mail to followed by a colon and then followed by the actual email address of the user that you are trying to send an email. But URI syntax has some limitations because URI has some reserved characters. As you can see, this colon is a reserved character. The slash is a reserved character. The question mark is a reserved character. Okay. The hash is the reserved character. Say if there is a hash in your path from your domain to the resource that the user is trying to request, the URI that is formed when they try to access that resource is not valid because you cannot use hash in between, as in you cannot use hash as your custom made path. So there are some characters that are reserved for URI, and you should not use it within your organization for referencing stuffs. Okay. Next, we come to URI encoding and referencing. Say you have this URI, okay, or URL. This is the protocol, I mean the scheme. This is the domain or the authority, followed by this is the path, and this is the query. Okay. Now, as you can see, what we did was after the path, okay, now there is a slash here, right? So URI encoding and referencing, what it does is the path, every characters, so every reserved URI characters can be encoded with its percentage symbol. Percentage symbol is percentage followed by the hexadecimal representation of that number. Okay. Yeah. So URI can be referenced in both absolute and relative way. So if you directly access this link, this is an absolute link because you are providing a whole link from start to the end. But say you are already in example.com/test. Now to access the further part, you can just provide /example and then proceed with it. You'll still be able to access the resource. Now, in an overview, what HTTP does is the client opens a TCP connection to the server, sends the request to the server. The server is in general trying to listen for incoming TCP connections. Once it reads the request the client has sent, it will send a particular response. So this is just an overview of how HTTP works. Now, I had to make the slide a little colorful for you guys to grasp the terminologies and map one to one to the example and the terminology. As shown, an HTTP request consists of methods, resources. Resource is the thing that you're trying to access, the protocol version, and client information followed by the body. If you try to search for this, which means you're trying to get, which is a type of method, we'll be learning it later. What you're trying to get is the resource. The resource is index.html. How you're trying to get is the protocol version and followed by the version. So it is HTTP 1.1. Now this whole thing is method, resource, and protocol version. The next is the client information, the host, the user agent, and the connection. We'll see what these mean in the later slides. We'll move forward with HTTP request methods. So there are multiple methods in an HTTP protocol. So we'll just go ahead with just two because those are the widely used ones. The widely used ones are get method and the post method. So get method was initially made in order to request a resource from the server to a client. And the post method was made to make a request from the client to the server such that the server makes the necessary changes on the data that was sent from the client. Okay. These two methods are basically the most widely used. Will not go into put, head, delete, and all those stuffs. Okay. I will move forward with this. So now if you try to do this get slash http 1.1 and say you are already in google.com, the slash is relative to google.com. So your current resource is still google.com. Okay. Now this is the method, this is the resource. So currently the resource is slash and google.com. So in total it is www.google.com slash. Your protocol is HTTP, the version is 1.1. If you try to access this whole method request, you will be provided with this response. So we'll get into detail what this response actually means. We'll see this when we discuss the request response part of HTTP. Now, forms are also one type of request because the method, it contains a section where we have to specify what type of method it will pass it on as. So here, as we can see, this HTML part of the slide, which shows it contains an input for username, it contains an input for password, and then it's a submit. So basically, this is a login page. Okay. Now, the action determines where the page will be sent to, as in where the values of these inputs will be sent to, and how it will be sent to is specified by the method. Okay. Now, once the submit button is pressed, what HTTP does is collects the two inputs here, that is the username and the password, passes it to index.php through a post method. So this is how a modern, as in a form request or form submits are done. Now let's get to the response. Now once you request a resource, the server will respond to you with a response. Now this response consists of protocol version, status code, short reason, headers, and body. Now the first line that you see, this is the protocol as we have known earlier. This is the version, then followed by the status code. So there are multiple status code. I guess the famous status code is 404, which is, I guess you know, which is resource is not available. This is the short reason for this status code. And these are the headers. So headers contain multiple things, but I've not listed every header that contains. We'll see it while I demo this stuff. It contains date, it contains when it will expire, it contains what type of cache should be there. So this is a MIME. A content type which they have specified is a MIME. We'll discuss this later. And this whole red color thing is the header. And the black that you see is the body. And that is the actual response to your request. The rest of the part is for the HTTP to understand and manipulate, not manipulate, to display your data as it was requested. And the data that in response came in is shown in black. Okay, so what is a MIME? So a MIME is something, now as you can see here, the HTTP should know what type of response the server sent you so that it can render it to you properly. Right? Now it says the type it was received as was text/HTML. Now how is this actually formed? Okay, we'll discuss this in this slide. Now as you can see, A MIME type is a label used to identify a type of data. So say a server says this is text/HTML. Then the client will understand this is an HTML document and it can basically render it on the browser. That is internal. Now, what if the server says it was application/PDF? If this is what the MIME type of the response from the server is, then the client understands that it has to launch a PDF reader plugin that will enable the user to actually understand this document. So that is where a MIME type is really important. A MIME type consists of basically two parts, a type and a subtype, separated by a slash. In our case, it was the type was text and the subtype was HTML. There are these other possibilities such as application/PDF, application/MS Word, etc. Now we'll go on with hands-on. And before I go on with hands-on, do you guys have any doubt? Guys, any doubt? I'll take in some doubts now. Yeah, if you have some doubts, you can go ahead with doubts. No doubts? Okay, fine. Yeah, I'll wait for a minute or so for you guys to type in the message and comment. Okay, yeah, fine. Then I'll go with the hands-on part of this. Okay, now I'll have to see that if I stop sharing this, and if I want to share, if I want to share my application, I guess you're not able to see it, right? Yeah, my screen will be back in a minute. Until then, if you guys have doubt, you can ask me because I'm trying to get my screen back up. Yeah, so my screen is up. Now, I hope you're able to see this. I believe you're able to see it. Okay. Now, Curl is an app, as in a tool, which allows you to access. Yeah, should I zoom in more? I guess, yeah, that should be fine, I guess. Okay. So curl is something that allows you to make the request that we discussed earlier. So it is a tool that allows you to make requests. Now, say you want to access google.com. Basically, this google.com that I've entered is a resource that I want to access. So I'm the client, and the person who has this resource, that is the google.com, is the authority. So I send this request, and it provides me with something that I'm not able to understand it here, right? So what we can do is we can try to get the details of what it sent us back. So what we'll do is we'll do the curl with verbose. Verbose has in a little bit extra information. Same google.com. Okay. Now initially it did send us something. Okay. So this part is basically my request. Right. Now internally it is trying to connect to this IP address, which is google.com. Okay. Now once it is connected to IP address part, as you can see, it is connected to port 80. And that is the reason I didn't have to specifically mention here the port. Okay. Now, as we discussed, we can see this is the method that I sent as a request. So I wanted get, as in I tried to use this resource through a get method. The path was slash. Now it's not just slash, it is this slash preceded with the host. So the actual path is www.google.com/. So I try to access this with HTTP and the versions 1.1. So what tries, host is basically the authority. Okay. Now user agent is the way I try to access it. Now since I used curl, it is curl and then the version of it. Now say I tried to access it using a browser. It would either be Mozilla or something else. So we'll look into the part where I said we'll try to understand what the response is from the previous slides. Now this is the response part. As you can see, this bracket represent the request. Okay. And the reverse bracket of this represent a response. Now the response is HTTP version 1.1 with a status code of 200, which is okay. The date is, as mentioned, expires -1 means it doesn't expire anytime soon. It will never expire. Now the cache control is private, so all these are headers that it sent us. And this is the actual response to my request. So this whole thing is the actual response to my request. But when you see this in a browser, okay, let me change my screen. Now, if you try to see this in a browser, what you'll be seeing is now you're seeing this as the response. So this is a response that we just seen in the command prompt. But that was in HTML, and since it was a MIME type of text/HTML, the browser understood it is HTML and rendered it accordingly. So this is how a HTTP request and response takes place. Okay. Now we'll proceed with proceed with the next part. I forgot to tell, Postman is also a way to, so it is a mechanism to provide API services. It accepts your get method, post method, and much more. Now, do you have any doubt? Yes, I forgot to say that curl is not installed by default in Windows, I guess. You'll have to actually install curl. Uh, I'll try, there is a Linux service, online Linux service that you guys can use. Yeah, I'll send you the link to Slack and you'll be able to access this after the class. Okay. Yeah, curl is in Linux, I guess. Yeah, curl should be in Linux. Okay, now we'll proceed forward with Wireshark. So Wireshark is a utility or a tool that enables you to capture packets. In Linux, there is a tool called TCP dump. You can use TCP dump, but it is not a GUI tool. So it is a terminal-based tool, and have to know commands to run it. So if you're not familiar with terminal commands, you can use Wireshark. Okay, so in Wireshark, we'll look into web request methods. We'll look into what IP, MAC, TCP stream is. We'll see what ping and trace route is. Okay, so we'll directly proceed with the hands-on for Wireshark because Wireshark, it is better to learn through practice than, yeah, share my screen, go to virtual machine. Okay, so you can use any version of Linux. It is up to you. There is no restrictions on it. But since I had Kali installed already, I'm using it. It is not necessary that you use Kali for initial basic steps because I would say if you use Kali in the beginning steps, you will be overwhelmed by what it provides, all the features that it provides. Okay. Try using basic Linux, get comfortable with the terminal commands, and then try to move on with other OSs as something like Parrot or Kali. Now we'll try Wireshark. We'll have our web browser open. Okay, so the first thing that Wireshark needs is an interface to capture your packets. So the interface might be either the Ethernet connection that you connected the machine to the internet, or through Wi-Fi, or through any other different method. You can use it to capture traffic. Say I'm using Ethernet because since it is VMware, it is okay to use it. Then I start capturing. Now it's basically starts at work and starts capturing stuff. Now say I visit google.com, then I visit facebook.com, then I visit girlscript.com, Then I visit, say some random stuff. Okay. So say some random stuff. Okay. Let it be just these three. We can do it just by these three. Okay. Now, since we have done all these three, we'll proceed with our Wireshark now. Okay. So let's stop the capturing of packets, and now we'll try to analyze some part of it. Now, the first thing to understand is the way Wireshark displays information to you. I guess, are you able to see my, yes, but this is way too small, I guess. Can I increase the size of it? 1 second, I'll just try to increase the size of it. Yeah, I'll just see if I can. Guys, let me know if you can see, as in if you can read stuff from the screen, do let me know. Oh, I'm trying to zoom it in. No, this is not zoom. Okay. So what we'll do is the first thing that it displays is the number of packets that it captured, the time at which it captured, the source and destination, the protocol, the length of the packet, and some information about the packet. Okay. Now, in the protocols, you can see various protocols, say SSL, TCP, then we have DNS somewhere, DNS, then we have TLS. Okay. So there are multiple protocols here. Ah, yeah, Dushyant, can you let me know where the magnifier tool is? Yeah, I'm just looking for the magnifier tool so that you guys will be able to see it. Okay, we'll proceed with this, and I can, if you guys have any doubt, you can ask me. What we'll do is, okay. So what I'll try is, I'll try to copy the data there, and then we can discuss about it. Okay. So the first thing that we learned today was HTTP, right? So in filter, we'll try HTTP. Then press enter. So Wireshark will automatically filter all the traffic into those which only have HTTP. Okay. References. Yeah, I'm trying to make it visible to you guys. So just bear with me for a minute. Okay. But this is very, very bad. Okay, I'll try to reduce the length a little because this is too much of font size. Okay. So I'll just reduce it a little bit. Yeah, I guess now it is a little better. Okay, now since we have filtered out as HTTP, now these all packets that you can see, so these all packets are just HTTP packets. Okay. Now we'll try to go through what it displays. So this packet that it captured was captured at time 17th second from the time we started. The source was, say, some source. There is a destination it wants to go through. This is a protocol, the length, and the info. Now, the info that you can see is the previous segment was not captured, but the request that this packet is making is a HTTP request packet. This is the response packet. So as you can see on the information side, you'll be able to see the request and response. So every slide, every packet has its own details. So once you say you want to look into this detail, you can go here for hypertext transfer protocol details. Now you see that this is a post request. A post request followed the uh, resource name or URI, I mean the authority, followed by the protocol version, and this is the whole version. Now the host, now the agent. Now as you can see, here the user agent is Mozilla 5.0. So it understood that a request was made from a web browser called Mozilla with a version of 5.0 from a Linux machine. Okay. Then these are all the headers for the request. Now, the whole thing is the request packet, and that is why you are able to see just the request contents. Now let's look at a response packet too. This too is a request. Okay, we'll look through the response. Okay. So this was the response. Say a response was HTTP. So as you can see, all these things we discussed is what the Wireshark displays us. So now that we know what we are looking for, we can see, we'll try to look for content. Content. Next response. Okay, sorry, next response. Okay, I'm not sure. Okay, so we'll have to go to TCP. Okay. So now, since there are multiple responsive requests, you are not able to understand how a flow. See, first we went to google.com, then we went to Facebook, and then we went to GirlScript, right? Since we did it in concur as in one after another, it is not necessary that the packets that was captured was exactly one after another. It is based on how Wireshark captured the packet, and it is currently displaying the same way. Now, in the original packet capture, there are multiple TCP handshake connections, right? Now, you want to know how one particular connection is flowing. So, we use something called as TCP string. Say you want to know more about this packet. We'll take a packet that is way in between so that it will have some data in it. Okay. Now we go to follow and we go to TCP string. Now what it shows is the whole method as in the whole process in which the request and response is sent for this. As you can see, there's a post method in top, then comes the response for this, and then comes the data for it. Same is the case for other traffics. Now, say you want to follow something else. Say you want to follow this packet here. Say follow and then TCP stream. Okay, so here you can see data, but you're not able to understand it, right? Because this packet is starting with, okay, so this is where we are trying to access facebook.com, and the reason you're not able to understand it is because it uses TLS protocol, and TLS is an encryption protocol, and that is the reason most of the things are encrypted here. Okay, and you're not able to figure out what it is. So encryption also is useful here because if anyone intercepts your traffic, it is highly likely that they are not able to understand what it is. Okay, I guess that is enough for a basic of Wireshark. Okay, yeah, that should be fine for Wireshark. Now let's go back to our command prompt. So as we discussed, we'll go through ping and trace route. Please accept my screen. Yeah. I guess it is visible to you guys. I'll take doubts just after I show ping and trace route. So we'll go with the basics. So ping is an ICMP request which checks if one resource is online or not. So say ping, and you want to say see if Google is online or not. Okay, so say there was a reply from Google of 32 bytes, of 32 bytes, and of 32 bytes. Now let's try to ping something else. Ping 8.8.8. This is a valid address also. Okay. Okay, I'm not sure why the request is being timed out here, because initially also there is a request timed out, and even now there is a request timed out. Okay, so ping, what it does is it actually tries to check if a given resource is online or not. But it might also be the case that you are not able to send your packet, your request from your machine to the server. So the case might be both. One is the server is not available, the other is you're not able to request it. Now, sometimes you want to know how your packet is traveling, as in from your machine to the server, how is it actually going through? So you use something called trace route. I'm not sure it is trace out or trace route here. Okay, so it is trace route. Okay, so trace route is a tool which allows you to understand how a packet hops from one machine to another, and it displays some information about that machine. So let us try how it goes from my machine to 8.8.8. So I'm not sure. Okay, so I'll just stop it here because I'll be revealing my IP address after this, so I don't want to do that. Okay. I should have tried it via a virtual machine. I'll try to post this video through what do you call Slack, and you'll be able to get to know how Tracelet works because I don't want to reveal my IP address. I hope I did not do that in previous demonstrations. Okay. Yeah, I guess we'll take in doubts and then we'll start off with our next stuffs. Yeah, guys, if you have doubt, 1 second. 1 second. I guess. So, guys, any doubt? Is okay. So there is one doubt from Joshi Ner. Why protocol OSCP is mentioned is the file packets are for HTTP. Yeah. So OSCP is something called online status certificate protocol or something. So it is associated with HTTP. I'm not sure about it. Then Wireshark could not be. Oh, I was not able to install Wireshark at the last moment, so I didn't actually try installing it in Windows. No, it should show you wireless networks for Wireshark in Windows. So do we know that if the problem is in our request that is not being sent or the server is not there? Okay, for that actually you can use traceroute to see if your packet is actually going somewhere or not, right? So if your packet is being dropped right in the start, you know that there is something wrong with your connection. But if the packet is reaching, but the response is not there from the end, then basically it means the server is out. Just wanted to know, is there any major threat if your public IP is revealed? There is no actually major threat unless someone intends to do something with it. But it is a good thing not to disclose your public IP. It is same as your address, right? So why would you let anyone know what your address is? Yes, I guess you will see the packets. Okay. Is Nmap used for the same stuff? Nmap is the term Nmap itself means it is a network monitor. Sorry, network mapper, not monitor. Okay. So it maps the network for you, and you will be able to understand which. Yes, Nmap also generally uses. I think you're trying to tell about ping, right? So not every command in Nmap uses ping because there are other ways to make sure if a service or resource is online or not. Okay. So we will not be going until there because since it is a basic course to cybersecurity, plus I will not be covering network security and operating system security here. Can we have this as last topic as in we have not tried it in our PC the same thing? Okay, you mean to say that should we have it as the like should we practice on the last day or something, Sanjana? I'm not sure. How can I attach a malicious code with image? Oh, what do you want to do with this malicious code? You can attach a malicious code with an image, but you should find a way to trigger that once it reaches your destination. which means if you don't have control over the file after it reaches the destination, then there is no way you'll be able to trigger that malicious code inside it, right? So it is basically like a Trojan horse. So you have a malicious content inside a safe thing, but there should be some trigger for it to get activated. So if you implemented that trigger, then you will be able to do it. Will I be able to see my friend's packets using Wireshark if he connects to my laptop's hotspot? Uh, yes, but if it is, say, if it is, yeah, basically you will be able to see packets, but to understand, there are multiple ways of going about it. Okay, the best thing is do ask me on Slack and I will get you there, because since this is online, I don't want to actually tell it here. No, I want to say don't keep another hands on today itself. Okay, fine. I'll try my best because I'm not sure if there are much hands on after this or not. Okay, the main question is how to trigger the malicious code of the image, right? So I'm not sure about how to do it in image, but I can tell you one example. Say you have a MS Word or MS Excel file. So there is something called as macros. So macros is a set of instructions that you have already given the file to do once there is a trigger. Okay. So some people have their macros auto enabled. So once they download the file itself, their machine can get infected. For some machines you will have to enable macros by yourself. So for that you will have to, as in once the macros try to start, it will ask the user if they intend to activate the macros or not. So that is one way of going about exploiting macros in MS Word or Excel. Oh, okay. Yeah, I forgot to inform you what applications you need. Yes, sorry for that. Sorry, Sanjana. Okay, I guess we'll proceed forward with a little bit of what is left today. Tomorrow we'll be doing SQL injection and cross-site scripting. Let's proceed with okay web terminologies. Is it really too slow? I'm not sure. Okay, so in web terminologies, you should know what a cookie is, what are cache, and what is a session. Cookies are small details that contains a key value pair. Now, this key value pair is used to identify a client, as in a server needs to identify a client, right? This is where a cookie is used to identify a client, to authorize, to authenticate a client. So cookie gives you basically an identity to identify yourself to the service or to the server. A cookie uh, can have an expiry period, and some might not have an expiry period. As we've seen earlier, there was cookie expiry as -1. That means it will not expire. Others have some cookie expiration date. Now the thing is, why is it so bad that they say if your cookie is leaked, why is it really so bad? Because cookies provide a method for the server to authenticate, authorize, and identify you. People can generally impersonate you through the cookies that they can steal. So you should make sure that there is no way that a person is able to access your cookies. Okay, so that is basic cookies. Now, cache is something that your browser generally stores in order to make your response from the server a little bit faster. Say you're trying to access google.com. Say you already tried for 5 times, and then for the sixth time you want to access google.com. Now, the browser would have stored a little bit of cache when you previously accessed google.com. So it will, as soon as you request google.com, it will first send you the cache, and simultaneously it will ask for the request from google.com. Now, the cache is shown to you as the response, but it is actually not the response. Okay. The response is now once again cached into the browser. So it is a continuous process of storing the cache and delivering the cache. So cache just makes your response to your server a little faster. Then there is something called as sessions. Now a session, okay, it is better I go through the slide. So when a client sends a request to the server engines gives the client a unique ID, which is the session ID. Now, once the session ID is issued when the client is connected to the server. Now the server stores the session ID which the client is using through a cookie. The one main difference is session ID is maintained by the server, whereas cookies are locally stored in the client machine, as in local machine of the client. Okay. So the data that is in the session ID is replicated on the cookie so that the server can identify and authenticate you. And once you reconnect with the server, it will update your cookie with its new session ID. And so this is a continuous process. Okay. So you should understand the difference between sessions, cookies, and cache. Okay. Now, we'll keep browser development tools such as Elements, Console, Networks, and Application for tomorrow's hands-on also. So we'll go on with OWASP 10 and we'll wrap this session up. So OWASP is an organization which focuses on open web application protocol projects. Okay. So OWASP is Open Web Application Security Projects. It is a non-profit foundation. It provides multiple things. It provides tools and resources. It provides opportunity to network and to its community. It also provides education and training. The one thing OWASP is pretty famous for is its OWASP top 10 projects. So the top 10, currently the first vulnerability or issue that they are concerned with is injection. So injection flaws occur when someone is expecting data to be sent, but you actually send in code. So when they try to access your data, they're actually trying to run your code. And that is where an injection happens. The attacker hostile data can trick the interpreter into executing unintended commands. An injection is always done without any authorization, because if you have authorization, it can also be done through authorization, but you're not actually authorized to run that command. And that is why we say you don't have proper authorization to do so. Now, there are multiple injection attacks, say SQL injection attack, OS attacks, LDAP attacks. Okay, so we won't be going there. We'll just go through what are the top 10 OWASP vulnerabilities. Now, the next is broken authentication. Now, say the application is not able to correctly authenticate the client, and an eavesdropper or an attacker is able to impersonate you and you know, act as you and get the information that he wants from the server. So if the applications authentication and session management are implemented incorrectly, broken authentication is likely to happen there. The next is sensitive data exposure. So there are ways in, so generally API calls make it easy for the server and client to communicate. But you shouldn't implement an open-faced API calls that reveals important sensitive data of your organization. So this is the third one. I won't cover the fourth one, so just move on from the fourth. Okay. Fifth one is broken access control. Okay. So say there are unauthorized functionality that the organization didn't want other people to use, as in unauthorized people to use, but there is a way that you can exploit it, then there is a broken access control that you're trying to exploit. Then there is security misconfiguration, which is widely exploited. So once you are configuring your devices, your services, you should make sure it is patched regularly and updated regularly, because hackers do catch on with the newly patched versions of bugs and vulnerabilities, so that already known vulnerabilities should be patched and the security configuration should be updated. The next thing is cross-site scripting, which we'll be doing it tomorrow. I won't cover insecure deserialization. Yeah, I guess that's it basically. These two are just, yeah. So using components with known vulnerabilities is, say I built my system pretty secure, but I'm using, say, a router which is known to have a vulnerability. Then the system that I've securely built is of no use actually, because a third party component that makes your system vulnerable is of no use if you have your system, hardened. What I mean to say is, if you're giving the same privilege to a component which has vulnerabilities as that of your system, then there is no actual security that you're implementing, because there is same access privileges and the attacker will be able to exploit the vulnerabilities in the known components. Then there is logging and monitoring. So this is one thing that people usually don't do nowadays. So it is better to log and monitor. Once you log stuff, you should actually review it on a timely manner. So these are basically the top 10 OWASP vulnerabilities. Yeah, I guess. Yeah. Okay. Yeah, that's it, I guess. Yeah, I'll try to get a little bit faster next time. Yeah. Any doubt? Okay. If you want to keep your online privacy, make sure that you don't disclose your data by yourself to the internet. That is the one thing that you can really do about it. Yeah, I guess it is pretty late here. Yeah. So if you guys have doubt, you can uh, message me on Slack and I'll get you there. Okay. I guess some people, yeah, if you guys want to leave, you can leave because this is the end of today's class. Any doubts? I guess there are no doubts. Yeah. I'll wrap it up in like 5 minutes. So if you guys have any doubt, you can ask. Yeah. Then I guess I can wrap it up for today's session. Yeah. Thank you guys for staying. Have a great night. Oh, so you wanted steganography hands-on. Okay, I'll try my best to provide you with a video on Slack and you will be able to do the revision. Okay. And try to break the RS equation that I've left on Slack. Oh yes, it is morning here. Yeah, I'll do the same for ADS also. Yeah, do remind me to do the ADS and steganography on Slack. I might forget it. Okay, so what is hostile data? Hostile data is some data which makes your whole system vulnerable is a hostile data. Okay, uh, it is same as what do you call a malware. So malware is basically a hostile data. Oh, I've already answered this, Sanket. The best you can do is try minimizing the amount of personal data that you put online. That's it. Yeah, I guess there are no more doubts. If you do have doubts, get me on Slack. I'll answer it there. Thank you. Have a great night, guys.